get into 12.4. This is more on angle measurements and segment lengths. You're going to take a quiz on tomorrow, Tuesday. And part of this, you can use the note packet on the quiz and the exam. A lot of these stuff with arcs and these segment lengths just match up with the pictures and the problem and go ahead and use the notes. These are kind of tricky. Honestly, these are things that I don't necessarily have memorized. I relearn them each year. They just don't come up all that much. So that's why you can use your note package. Just know that if you see a type of problem, you know where to find it and look it up. All right, so if two chords intersect in the interior of a circle, right? So these don't necessarily go through the center, right? They just intersect in the interior. Then the measure of each angle is 1/2 the sum of the two intersected arcs. So what I'm going to do is find the measure of CD and the measure of AB. Add them together, divide by 2, and that's this angle right here. How do I know what this angle is? That angle 2 I just put in. Heck,
They're vertical angles.
they're vertical angles, and all vertical angles are congruent. So those two will be congruent as well. So for example, let's look at example 1. Let's figure out the measure of angle 1. So I'm going to add 90 plus 122, and then divide it by 2. That will give me the measure of angle 1. The measure of angle 1 equals 106 degrees. Try B yourself. See if you can come up with the answer. So let's first figure out the measure of this angle. I'm just going to call it angle A here. Okay. So again, I'm going to say the measure of angle A equals 70 plus 135 divided by 2. And I get the measure of angle A equals 102.5. So that's not what it asks. I can figure out the measure of angle 1 because these guys are a linear pair. So remember when these guys, whenever I see a pair of vertical angles, it's also the linear pairs we can solve too. So the measure of angle 1, since linear pairs are supplementary, is 180 minus 102.5. So the measure of angle 1 is 77.5 degrees. Questions on that item? Next. If an exterior angle intersects the circle, then the measure of the angle is 1/2 the difference of the two intercepted arcs. All right. So let's go ahead and see how this one works. All right. So now we're outside the circle, right? So when they're outside the circle, so we have the exterior angle. So the big arc is 268, right? How do I find that? Since these are tangent, if this is 92, this is 95. What's this part? 360 minus 92, and I get 268. So to figure out the measure of angle X, it's 1/2 the difference. So now 268, the big one, minus the small one, divided by 2, and that's the measure of angle X. 268 minus 92, divided by 2. The measure of angle X equals 88 degrees. Try B, and then we'll do C together. All right, so we have the exterior angle now. It's 40. So I know that 140 minus X divided by 2 equals that exterior. So to solve this, multiply both sides by 2. I get 140 minus x equals 80. And then subtract 140 from both sides. Negative x equals negative 60, so x equals 60 degrees. Now this one. Again, we're going to take the big plus 7, and then I'm going to subtract the smaller one. Put that in parentheses so you can make sure you distribute that negative 1. Equals x over 2. Remember, we have to divide this by 2, so the big one minus the small one divided by 2 equals another side. So the first thing I'm going to do is multiply this whole thing by 2. So I end up with x plus 70. And I'm going to distribute this negative 1 right now. Minus x minus 30 equals x. And notice those guys will just cancel each other out. So x equals 70 minus 30, 40 degrees, or 40. And let's figure out the measures of each of these. So 40 plus 70, that's 110. And then 40 plus 30, 70 degrees. And then 40 divided by 2, 20 degrees. So 110 minus 70 is 40 divided by 2, 20. Next one. All right, so I apologize for the scary nature of this next problem. All right, but this is a practical use for this. So the danger circle is the area out at sea where a ship is in danger of hitting rocks. Lighthouses are set up to warn ships. They create a circle with the arc as shown below. If the boat travels inside the circle, it is in danger. See what kind of danger? Sharks, rocks, pirates, General Sherman and his tank. If the boat is outside, as shown below, it's okay. The arc between the two lighthouses measures 120 degrees. So this right here, 120 degrees. A ship's captain measures the angle from the bow to be 55 degrees. And this is 55 degrees. Is the ship safe? And then what angle must he be at in order to be safe? All right, well, let's solve for this right here. We'll call that x. If x is a positive value, the ship is obviously outside the circle. So let's see this. 120 minus x divided by 2 equals 55. I'm going to multiply both sides by 2. 120 minus x equals 110 degrees. Subtract 120, negative x equals negative 10. So x equals 10. So this arc measures 10 degrees. So is the ship safe? Yes. The ship is outside the danger circle. So the further out the ship is, right, the smaller this angle at its bow is going to be, right? As it approaches the danger circle, right, as it approaches the two lighthouses, this is going to spread out further and further, right, and get bigger. We can revisit what we learned in the last unit, right, to figure out what is the measure of the angle if the ship is right on the edge there. Right, so what is the measure of this angle? All we need to do is, since that is an inscribed angle now, an angle on the circle, right? We can take 120 degrees, divide it by 2, right? It's half of that part. So 60 degrees would put him right on the edge of that circle anywhere, right? So any angle measured less than 60 degrees, the boat is safe. Any angle less than 60 degrees, the boat is safe. So now you can all be ship captains.
Thank you.
Questions on that so far? Next thing. If two chords intersect in the interior of a circle, then the product of the segment lengths of one chord is equal to the product of the segment lengths of the other chord. So let's see what this is. So EA, we have that section, times EB equals EC times ED. So the way we set these type of problems up, 9 times x equals 3 times 6. So 9x equals 18. What does x equal? 2, right? So we take the product of each of these and set it equal to the product of those. All right, let's see about this one. We have 3x times x minus 1 equals 2 times 4. So let's go ahead and 3x squared minus 3x equals 8. Subtract that over. 3x squared 3x minus 8 equals 0. Then we'll come up with two numbers multiplied together equals negative 24, but add together equals negative 3.
What are we selling?
7 times 4 is 28, not 24.
Negative 5 and 2.
Negative 5 and 2, that's negative 10.
Oh, never mind.
So remember what we're doing. We're negative 24 and negative 3. I can't come up with anything either. We have our old pal, the quadratic formula. You remember that from earlier this year and from last year. So we need to identify our A, B, and C. So the opposite of B, positive 3, plus or minus the square root of B squared, which is 9, minus 4 times 3 times negative 8, all over 2A, which is 6. So remember, if we have a negative in here, it's going to make that positive. So we have 12 times 8, which is what, 96? And then plus 9, and I get 105. So 3 plus or minus the square root of 105, all divided by 6. And the square root of 105, 10.2. So 3 plus 10.2 divided by 6. And then 3 minus 10.2 divided by 6. And I get 2.2 for x. or negative 1.2. Will the negative solution make sense? When I plug it back in, negative 1.2, so we'll have a negative length right here. So we're going to ignore the negative solution. And our answer is positive 2.2. All right. Now this one I think is probably the trickiest one, or the easiest one to make mistakes. It's not so tricky as long as you can match it up. So now, just like we did with the angles outside and the angles inside, now we're going to do the lengths outside after we just did the lengths inside. So now if we have two secant segments meet outside of circle at point E, then the products of the secant segments and their external secant segments are equal. So now this one, color code these, we have EA, this little outside section, times the length of the whole thing equals EC, that outside section, times the length of the whole thing. All right, so we need to remember to go ahead and add these together. So let's see how this one will work. So first, we need the length of this whole thing, right? 9 plus 11 is 20. And then the length of this whole thing is x plus 10. So the outside section times the length of the whole thing equals the outside section times the length of the whole secant. So we get 10x plus 100 equals 180. 10x equals 80. X equals. Try to do example B on your own. All right, let's check this one. So we're given the whole length. So x, the outside, times the length of the whole thing, 72, equals the outside, there's 40 here, times the length of the whole thing, which is 78. So I get 72x equals 3120. Divide by 72. X equals 43 and a third. All right. And the last thing for today.
Oh my God, I'm so fucking nervous.
Now,
Jeez.
if a secant segment and a tangent segment meet outside the circle, then the product of the secant segment and its external secant segment is equal to the square of the tangent segment. All right, so let's see what this one is. So we have EA, the outside, times the whole thing, just like we did in the last one. But now we have a tangent, so I'm going to take this section and square it. All right. So, outside section, and then the length of this whole thing is x plus 2. So we have x times x plus 2 equals 5 squared. So x squared plus 4x equals 25. So what this is set up for now is for completing the square. Remember how to complete the square. So what I'm going to do is take half of that b squared and add it to both sides. So half of 4 is 2. 2 squared is 4. So I'm going to add 4 here and add 4 here. What I end up with is creating the perfect square, x squared plus 4x plus 4, which turns out to be x, and whatever is half of that b goes right there. Equals 20. And now I can go ahead and take the square root of both sides. X plus 2 equals positive or negative square root of 20. And then subtract 2 from both sides. X equals negative 2. And I'm going to ignore the negative solution because we can't have a negative length up there. Plus the square root of 29. and I get x equals 3.4. All right. Last example. Let's start by solving for x first. The product of these equals the product of those. So 12 times x equals 8 times 18. So 12x equals 144. X equals 12. So that's 12 here. So now the length of the external 2 times the length of the whole thing, which is 12 plus 12 plus is 26, equals y squared. So 2 times 26 is 52. So y squared equals 52. And then I'm going to take the square root of that. And we get y equals 7.2. And I can ignore the negative solution since you can't have a negative. All right, only one more section to go for geometry for the entire year.